this history. This is a video regarding leakage current. It's a continuation of a prior video which we just did about transistors and FET outputs. When we first had a problem with these FET outputs, knowing they're going to fail, we put this relay in. It's from Allen Bradley. Now I know there's a leakage current factor in a transistor, and that can cause, you have your inrush current into a relay, you have your holding current for the relay, and you have your dropout current for a relay. I asked Allen Bradley up front, I said, guys, I think that if you take this relay and put this relay with that output, there's going to be a potential problem of the leakage current through this transistor, this FET, not letting that relay drop out. We got a few of these in the field, and we had sporadic problems with some relays go in and out just fine, and some don't. It took me 4 months of hassling Allen Bradley and driving back and getting technical papers where we found out we were within a couple microamps of the dropout. The leakage current on some of these FETs, they have tolerances logically, because every device has tolerances. The leakage current flowing through here was enough to keep the relay from dropping out if the relay specifications were at one end of the extreme. So if you had the FET and the relay both matching up just right, the FET would turn on the relay. When the FET turns off, the relay doesn't drop out. The way you get around that is putting on a shunt resistor, which is shown here. What the shunt resistor does, it's a resistor which goes across here. Actually, it goes across the load. So the leakage current goes through another resistor, bypassing the load. It has to be a very low resistance resistor to avoid other problems, but a shunt resistor solves a problem, and this did cause a problem for us in the field. Live and learn. Allen Bradley finally fessed up. We got the resistors, sent them out to the customer. If they connect them across the power feed, the coil of this relay, then it will drop out when this turns off. So you can have, aside from just FETs leaking and failing and being damaged by voltage spikes, and valves cause inductive voltage spikes, you can also have the basic leakage current causing relays to not drop out unless you size things right. And this is common both in the world of electronics, and it can be common in the world of electromechanical. So if I go back to the pre-electronic world, back to the electromechanical world, this dropout issue was still there. You had to be aware of it. Or you could pull in the relay, and when you want to turn it off, it won't turn off. It stays in, because your pull-in current is higher than your holding current, and it's higher than your dropout current. So that's a second little thing about biasing drainage resistors to draw off leakage current to let the relays drop out when the transistor turns off. That's the end of this one.